Okay, Ethan and Justin and Remington and I'm not sure who else. Remington's taking a quiz, so I'm recording for her also. Well, Justin's taking a quiz too. Okay. All right, so we are on example 6. We started this yesterday. We were doing absolute value and moving them around. And we went through 1 through 5, I think, fairly quickly because we're just doing the transformations, right? Okay, so this one is starting to do stretch and compression. So if we're looking at this guy, we're just trying to describe what is happening to him. So the 5/2, if you use your little sheet, that's fine. The grid that you have that has all of the transformations on it, that would be a helpful tool to use. But hopefully you're getting to the point where you can kind of maybe recognize these. 5/2, since he is on the outside, he is a vertical something. And 5/2 is a number that's bigger than 1. So 5/2 is going to be a stretch. It's a vertical stretch by 5/2. So what that's going to do to the graph is if my original guy is going up 1/1, up 1/1, he is going to go up 5/2 to get to my first point. And up 5/2 this direction to get to my first point. So that's that. Yep, you can sit there. Yep, he's underneath there. Okay? So that's how your absolute value is going to change. Instead of up 1/1, he's up 5/2. My slope is steeper. Yeah? Sound good? Okay, next one. We're going through these really, really super fast. Now, this one, the 2 is inside. Okay, and whenever he's inside, you have to do something weird, right? This one's going to be horizontal, but before we decide, we have to flip him first, right? The flip of 2 is 1/2, yeah? And 1/2, if I'm multiplying by 1/2, is that stretching or compressing? That is compressing. So horizontal compression by 1/2, okay? So now think about what a horizontal compression does. Horizontal compression is taking something here and I'm compressing him this way. Okay, so I'm squeezing him this way. So a lot of times that ends up making him taller, right? So horizontal compression, he's gonna like get shoved over. And so he's kind of like up 2/1, up 2/1, kind of like a vertical stretch would be, right? Horizontal compression, vertical stretch.
Decimal, how would that be?
If he's a decimal, like let's say 0.8, I think, right? Okay, and let's say he's 0.8x inside. What is 0.8 as a fraction? That's what I would do first. 8/10 or 4/5. So this is 4/5x. But since he's inside, I'm going to flip it, right? So it's 5/4, right? Okay. Is 5/4 going to make him bigger or smaller? Bigger. So that's a stretch and that's horizontal. Yeah? So make him into a fraction first, then flip the fraction. So he's still going to get graphed like with the slope of 4/5. Yep. So like up 4/5. Like kind of like this one was still, even though it was a 2 inside of there, it's a horizontal compression by 1/2, yes, but it's going to go up 2/1, up 2/1. So you still graph him as the number inside of the equation. Yeah? That slope? Oh, my eyes are like burning. Is anybody else's eyes burning?
Number not flipped? So
You
it's
graph him
up
as the
to
slope
it
of the
goes up
number
to
not
it.
flipped. Correct.
Big
Okay.
calculator.
All right, let's keep on going. This guy right here is 1/3 x. Is that vertical or horizontal? Vertical because he's on the outside, right? Okay. And we don't flip the number, so we keep it 1/3. Is it a vertical stretch or compression? Compression. So vertically, I'm compressing. That's what I am, right? That's what short people are. Vertical compression. So I make him shorter. And now the blue one was the original, but instead of going up 1/1, I'm just gonna go the slope up 1/3. Up 1/3, or up this way over 3, right? So that makes them a little bit wider, right? Because if I vertically compress, that's the hard part about being short. Like you take my weight and you put it on somebody who's like 6 foot and they're going to be like super skinny, right? Darn it. So I don't get to weigh as much because I'm shorter. That's not fair,
That's why Katie and Greg
Right?
make less.
right? Like big people, you guys get to eat more and then it doesn't affect you. But like you, if I eat the same amount as like a 6 foot tall person eats, then like I'm a balloon, right? Not fair. Not fair. What? For Harrison. Yeah, that's because he's still growing though, because he's burning calories and burning calories and burning calories. I know, boys, it's really not fair. You guys get like
Short
easy,
boys.
you know.
Short
Yeah,
boys.
yeah. Well, but like
I don't know,
boys,
crazy.
boys in general, your metabolisms are just like
Yeah.
on it. Like girls, we just get fat. It's just not fair.
Wow.
It's not fair. Not fair at all.
Loaded.
Okay. All right. Let's go down to this one. Now we got lots of things going on to this one. So example 9. Woo! Buckle up. Example 9. We've got this guy going on here. How many things are happening?
3.
3. 3 things. 1, 2, 3. And we're going to do all 3 of those things, and we are not going to make a table. Okay? All 3 things. Now, which one are the 3 things? You've got a negative, and you've got a plus 3, and you've got a plus 5. Okay, now we've got to decide which one is happening first. So if I plug a number in for x, would the negative, the 3, or the 5 come first?
Negative.
The plus 3 would come first. Then what would happen after that?
Negative.
Then the negative, then the
5.
plus 5. Okay, so the plus 3, since it's inside there,
It's
is left 3. It's like the opposite of what you think that it is, right? Okay, plus 3 actually means the left 3. Okay, the minus on the outside is over the x. It's a reflection over the x, and then the plus 5 moves him to the up 5. And if you want to use arrows, you sure can. Okay? All right, so the hard part is like graphing all 3 of those at the same time. That gets kind of hard.
Does it have to be in order?
Okay?
We don't have to do that in our problem. It doesn't matter.
I won't make you guys be in order, but like when we get to like trig and some of the upper math classes, I do make sure you have to have them in order. And it gets familiar at that point that it's no problem putting them in order. But if you put them out of order, I will say, okay, I won't count it wrong. Okay? All right, so this guy, we are moving him to the left 3 and up 5, and he is flipped down. That's what he looks like. Okay? Flip down, left 3, up 5. Okay? All right, this guy, this one right here, let's talk about what he's doing. Now, how many things are being done? Because a lot of people say there's only 1. But there is actually 2 things, okay? The 3/4 is one part, and the negative is another part. Which one's happening first? It doesn't matter. They're both happening at the same time. Because you're multiplying, they're both happening at the same time. So let's do the 3/4 first, and let's do the negative. 3/4 is on the outside, which means he is a vertical, okay? And we don't flip it, right? So a vertical something by 3/4. He is a compression because 3/4 is smaller, right? Okay? And then the negative, because it's on the outside, is over the x-axis. If you're still struggling with these rules, use that sheet, okay? Until you get familiar with them. If you are like rock awesome at these, that's super good because next year and the year after that, and the year after that, and the year after that, like all the rest of the years in high school are going to be way easy for you because like we do these a lot. Okay? And it's super nice because never again will you have to make a table if you know how to use these rules to cheat, right? I don't know. Because if you don't know the rules, then you have to use the table. There's no other option you have, right? You have to graph them with the table. They plug numbers in. So they are like, let's plug in -6. If I plug him into here, -6, the absolute value of -6 is +6, and 3/4 of 6 is like -8 or something like that, whatever it is. Oh, no, they plugged in 8. I don't know. I don't even know what they plugged in. Like they just made a table, and then they plotted those points. Boo. So we have this blue guy, right? And 3/4 means instead of going up 1 over 1, up 1 over 1, we're going to go up 3 and over 4, right? So he's a little slightly wider than what he was to begin with, right? Up 3 over 4, except the negative means that I take that black one now and I flip him down, right? Okay, so the 3/4 moves him like this black one. It makes him this one right here. And then the 3/4, or the negative is going to flip him down, okay? All right? So it almost looks like they didn't even do anything, that they just flipped him down. But he is slightly skinnier, not skinnier, slightly fatter and shorter than what he was to begin with. Okay, if I just would have flipped him down, he would look like this. Okay, so he is slightly wider and shorter. Okay, that's what the 3/4 does. Okay, all right, let's keep on going. Let's do this one. How many things are happening to this one? This is example 11. There's 2 things. Which one is happening first?
The 4.
They're at the same time, so it doesn't matter. We'll do the 4 first, and then we'll do the negative. Now, 4, because it's on the inside, means we have to flip it, right? It's 1/4, and that means it's horizontal. And if it's 1/4, is it stretch or compress? Compression. Horizontal compression. That's making it skinnier, which makes it taller, right? The negative on the inside makes him over the y-axis. Okay, now, here's the interesting part. If you take an absolute value and you flip it over the y-axis like this guy, I'm spinning him around the y-axis. It doesn't do anything, right? It doesn't do anything. That's stupid. It is kind of weird. Okay? Well, all that really matters is the 4. So it's making him taller, right? Instead of up 1 over 1, he's up 4 and over 1, and up 4 and over 1, and that's what he will look like now. Okay? So the spinning over the y-axis actually doesn't change him. which is kind of funny.
Then what's the point of the...
Right, you
Unless
shouldn't
it's
even
not
put the negative
set
in there.
on the y-axis. If it's an absolute value, then it's not starting at the origin.
Correct.
I mean-
Yes, yes. If you move him first, then it would matter. Yes, you're right. You're right. Okay. All right. Last couple ones they have that right there. Let's do number 12, example 12. I'm skipping over a lot just because we did this all on that sheet, right? Okay, so this guy, how many things are happening on number 12? 3?
Okay,
The
that's
negative is minus 4. It's not multiplying by 4. Yeah. So there is only 2. Which one comes first,
Plus
though?
1.
The plus 1 comes first and the minus 4. Okay, 1 is moving him to the left 1 because it's plus 1 inside, and then down 4. Left 1, down 4. Okay? So this one is not changing the shape of him at all. He's staying the same shape, this blue. I'm just moving him left 1.
Oh, no.
They did not move him down 4 yet. They showed both of them. So this one is left 1, down 4. So the orange one is actually, the yellow one is actually the correct one. They showed both steps. Left 1, down 4. Okay? Good? Okay. All right. Example 12. Let's go to 13. Holy moly. What?
2x.
Okay. How many things are happening?
3.
This one's tricky.
3 times x is happening, right?
2 or 3?
Two.
There's only
2.
Well,
There's only 2.
but
Which one happens first? The 3 or the minus 6?
3.
The 3 and then the minus 6. Okay, the 3 is inside and he's being multiplied. So that means it's a horizontal. What's the factor going to be? 1/3. We've got to flip it so it is a compression. You're right. Horizontal compress. So I'm compressing him horizontally, which is going to make him taller, right? And then what's the minus 6 do?
Right. 6.
To the right 6. Okay, so I'm making him taller. I'm making him up 3 over 1, up 3 over 1. Ooh. Up 3 over 1, up 3 over 1. So this is what he looks like, right? But then I move him to the right 2. Yeah?
Couldn't we just start?
Actually, they moved him to the right 6. Not, what?
It's
Maybe
probably
each
going by
one
a
is
different
3.
number.
Oh, yeah. Okay, there you go. Good?
Because there's not 6 rows going.
Yeah. Right. They could be going, like, by a different thing. Okay? All right, 14. We're almost to the end. We'll skip 15, but we'll go 14. This is the last one. How many things are happening?
2, 3.
3. Looks like there's 5, but there's 3.
No, there's 3.
It looks like there are 5, but there's only 3. This negative, this minus 3, and this plus 5. Okay, so 1, 2, 3. Which one is happening first?
Minus 3.
Minus 3, that is to the right 3. Okay, because it's the opposite signage of what you think. Then what happens? The negative or the 5?
The reflection.
Over the x.
Over the x. That's flipping him down, right?
Up 5.
And then up 5. Up 5. Okay, so we took him and we moved him to the right 3. 1, 2, 3, and then we flipped him down. Okay, that's what he looks like. And then we moved him up 5. So now he looks like this one. Yeah?
Yes.
Okay. I personally think moving him left, right, up, down, and flipping him is easier. When you start to do the stretch and compression, change his slope and make him like a skinnier or fatter one, like that's where it gets a little bit tricky. Okay, so be careful as you're doing these steps. Good? Yes, sir.
How do you know which ones to do first?
Oh, good question. I think I told you this a while back, but it's been a while. So, Harrison, we said that the negative is doing something, the minus 3 is doing something, and the plus 5 is doing something. Here's how I judge. Ready? If I'm plugging a number in for x, would I apply the negative to it first? Would I subtract the 3 from it first, or would I add the 5? I would subtract the 3 from it. That's the first thing I do. Then, from there, would I attach the negative, or would I add the 5? Attach the negative to it. That's the second thing. Then I would add the 5. Now it's going to move them up 5. So that's how I judge. If I plug a number in for x, which one of those things do I do first? Good question. Yeah? Okay, here we go. I think you can do it. 1 through 18. Let's do all.
What?
Woo!
Even.
Yeah, you already did 1 through 3. And it's really fast. And then on the back page is evens, so it's 20 through 34 evens.
What, 34?
Yeah.
No.
Don't eat it.
20 through 34 evens. 1 through 18, all 20 through 34 evens. There you go. 1 through 18, all 20 through 34 evens.
Unless you can do them all in 5 seconds.
I could do it.
Yeah.
Said who?
We did, how many examples? We did 9 examples in about 10 minutes.
I'm on 20.
So that shouldn't take very long.
I have a question. How do you do 7 through 12?
We didn't
Yeah.
do 23.
7 through 12. Ooh, 7 through 12. Oh, this is good. This is good. Okay, now, 7.
And then down to
7, 7. Is he still going up 1 over 1, up 1 over 1, up 1 over 1?
Yeah.
Yes, so we didn't change. We didn't stretch or compress him at all. The only thing we did was move him to the left 2. So if we start with y equals the absolute value of x and we know we're moving him to the left 2, how does that change his equation?
Plus 2 inside of the...
He's plus 2. Yep. Y equals x plus 2. That's what he will look like. Okay? I think all of these you're just moving him left, right. Okay? So
Is it
that's
okay
what
if we just-
7 should look like.
Is it okay if we didn't write the
Does it have to
y
be y
equals?
equals?
Did you just do absolute value x
Yeah.
minus x plus
Yeah.
2? That's fine.
Okay.
Yeah, that's fine.
I was about to say.
That's fine. Okay? Good, good. Anything else before I stop the video? We're doing a good job. I'm proud of us.
When you have more than one step and they're
Woo.
both...
Oh, we also don't have.
Are you looking at like let's say number 12? 8? What's 8?
And 12. Like, how do you do it with
8.
12?
Sure, let's do 8. Okay, so 8 is doing what? We start here, we're going to the left 1 and down 2. Okay, so y equals the absolute value of x plus 1 and
Then minus 2.
you got it. See, look, don't you tell me that you don't know how to do these, Brexton.
Right at the end, Sedana, we should be fine.
Yeah.
Okay, Lee.
So there's number 8, if you need number 8. Okay,
Graph
good?
the graph function.
Where is he?
It's
Graph
the
what?
domain and
I'm
range.
26. I'm not doing
26 to 32, their domain and range equals.
No. 26 through 32, just tell me what is being done.
That's all you want.
Just tell me what
Just
the,
like we
just
did
tell me,
above
just
it.
like what we did up above. Yep. You don't have to graph.
Domain and range.
You don't have to do domain and range, just tell me what it is. So yeah, when it says graph each function, don't do that. Just state
It'd be a
the transformation.
horizontal compression by half.
Yeah,
To the
Yeah.
left. I mean,
on
to the right
26,
two,
and then to the right 2, and then up 1.
Oh,
Yeah, absolutely. Yep, you got it.
Wait, what did you say?
Yeah, yeah.
Oh, yeah.
Okay.
Horizontal compression by
All right,
one
goodbye.
half.